Let's dive in. Today, we're going on a trip, a journey to the very edge of what we think we know. And our map? Well, it's the cosmos itself.
I want you to think about something for a second. What if everything you experience every single day, all the stuff that feels so real and so big, what if all of it is just a tiny, tiny dot in something, well, something so unbelievably vast that we can't even really wrap our heads around it? To even begin to understand this, we need a starting point, right? A familiar anchor in this huge cosmic sea. We need to start at home. And that anchor, of course, is our home, Earth. I mean, from down here, it feels absolutely massive, right? You've got continents, oceans, entire civilizations. It's pretty much our definition of huge. But let's get our first big reality check. Here's our Earth, right next to our star, the sun. And yeah, you immediately see how what we think of as vast is, on a solar scale, just tiny. Get this. You could cram over 1,000,000 Earths inside the sun. 1,000,000. The difference in size is it's almost funny. All of a sudden, our entire world becomes nothing more than a single grain of sand. Okay, so that giant star that can swallow 1,000,000 Earths, it turns out it's not really that special after all. Yep, that's right. For all its incredible power, our sun is, well, it's just an average star, a yellow dwarf. In a universe absolutely packed with real giants, our sun is just average. So, let me introduce you to UY Scuti. It's a hypergiant star. And just to give you a sense of its scale, if you swapped it out with our sun, its surface would reach all the way past Jupiter. It would literally swallow Earth, Mars, all of them. And here's where it gets really wild. Stars like our sun and even monsters like UY Scuti, they're all just tiny little parts of a massive cosmic city, our home galaxy, the Milky Way. To even talk about these kinds of distances, we need a totally new way to measure, a light year. Now, it's not a unit of time, it's a unit of distance. An absolutely colossal distance, nearly 6 trillion miles. It's so big that miles and kilometers just become useless. So, how big is our galaxy with this new way of measuring? Well, even if you were traveling at the speed of light, the fastest thing possible, it would still take you 100,000 years just to cross from one side to the other. Just think about that. That's the scale of our home. But we're not done yet. We've gone from our planet to our star to our galaxy. Now, you might want to brace yourself for the biggest leap of all. And no, that is not a typo. Scientists think there are around 2 trillion galaxies just in the part of the universe we can actually see. 2 trillion. Every single one of those is a galaxy like ours, or maybe even bigger. You know those deep space photos where you see all those little dots of light? Each one of those dots is an entire galaxy. So what does a number like 2 trillion even mean? It means 2 trillion islands of stars out there, each one with billions of its own stars surrounded by who knows how many planets. That's 2 trillion chances for new worlds, and maybe, just maybe, for life. And here's another mind-bending thing. Because these galaxies are so incredibly far away, the light you see from them has taken billions of years to get to us. So we're not actually seeing them as they are right now. We're seeing them as they were in the super distant past. It's like the night sky is a giant time machine. But beyond all that light, from all those trillions of galaxies, the universe holds some really deep secrets in the darkness. Things that basically challenge everything we think we know about reality. I'm talking about black holes. These things are the ultimate cosmic trap. It's a spot where gravity gets so intense, so strong, that it literally bends space and time. And once something crosses that line, the event horizon, that's it. There's no coming back. Not even light can escape. And this isn't some far-off, exotic thing. We've got one right in our own galactic backyard. Right at the heart of the Milky Way, there's a supermassive black hole that basically holds our entire galaxy together. So what actually happens inside one? What's on the other side of that point of no return? You want to know the honest answer? We have no idea. We just don't know. All our laws of physics, everything we think we understand, it just completely falls apart. Which kind of brings us full circle, doesn't it? After seeing the real scale of everything, from our little planet to these infinite black pits, you just have to wonder, where do we fit into all this? Everything we've talked about so far, all the stars, all the galaxies, that only makes up a teeny tiny fraction of what's really out there. The rest, it's a complete mystery. The great unknown could be hiding anything. We're talking entire new worlds, maybe even undiscovered civilizations, or forces of nature we haven't even dreamed of yet. So the next time you're outside on a clear night and you look up at that sky, I want you to remember all of this. Remember the scale, the mystery, the sheer beautiful impossibility of it all. Because you're not just looking at a bunch of pretty lights. You are looking straight into the face of the great, boundless unknown, and wow, what a spectacular view it is.